Hi everyone, today we are talking about combinations, so let's dive right in. Our example that we're going to be learning about combinations through is a problem where we would get to pick 3 favorite colors. So here are color options. You've got green, yellow, orange, pink, purple, blue, and light blue or teal or something. So if I were to pick my favorite 3, I might pick these 3, but maybe you might be missing Wheat North, pick your blue and gold, and then say, but you also love green, right? So we could start making a list of these. Take kind of a while. I got started and then I got pretty tired because this was becoming quite a long list. So far, I already had 30 different ways that I could pick 3 colors, and I only made it through starting with green. Now, we learned with Mr. Johns that we could have done this with a formula, right? So here's our permutation formula, NPR. And so for our situation, we'd had 7 colors and we were getting to pick 3 of them. That would mean that there were 210. I only listed out 30. There were 210 different ways that we could have done that. But if we look a little closer at these values, I noticed that green, yellow, and blue, what I said maybe you had chosen, started to come up more than once. We had green, yellow, blue, and then there was green, blue, yellow, or blue, green, and yellow. But if we were just getting to pick 3 colors, I felt like these were kind of repetitive, and they were being counted several times within that number 210. So in that situation, if order doesn't matter, the order in which we pick our things doesn't matter, then instead of using what we were calling a permutation, we're going to be instead looking at something called a combination. So again, combinations are what we're going to use when order does not matter. If the order that the colors we chose did matter, like green was going to be painted on the ceiling and yellow was going to be on the walls and blue was going to be on the floor, if they each had like a really specific purpose or something, maybe the order would matter. But in our situation of just picking 3 favorite colors, it definitely doesn't. And so we're going to explore combinations. So here are our formulas. For permutations, our formula looked like this. It was N represented the number of elements that we were getting to choose from, so number of options, versus R was the number we were choosing. So we maybe had 7 colors to pick from. We were choosing 3. That's how I got that 210 using that formula, n factorial over n minus r factorial. But in a combination, when order doesn't matter, we're going to have a lot less total outcomes. So the formula looks like this. It's almost the same. We still have the n factorial in the numerator. In our denominator, we still have the n minus r factorial. But notice right here, we also have this r factorial. Dividing away r factorial gets rid of all of the extra repeats that we were seeing in that example. So let's go ahead and solve that out and figure out what the combination of our 7 colors and choosing 3 would give us. So I've got the formula up here on the top left, 7C3. So 7 is our n value, 3 is our r value. So I'm going to substitute those values in. And now we know what 7 minus 3 is. So if we're doing this by hand, we can turn that into 4. And what factorial was 7 factorial is multiply 7 by every number smaller than 7 down to 1. So 7 times 6 times 5 times 4 times 3 times 2 times 1. Same thing with the 4 factorial and the 3 factorial. Continuing to simplify by hand, I can notice that we have a lot of repeated numbers in the numerator and denominator that could get reduced. The 1s, the 2s, 6 is the same as 3 times 2. If we reduce as much as we can, we're all the way down to 7 times 5. So we've determined that 7C3, so figuring out how many different ways can you select 3 from 7 when order doesn't matter, is only 35, which is much smaller than our permutation at 210. Now, every time you have a problem, let's say our problem was you were going to give awards out at the art show and you walked around and you were going to get to pass out 3 ribbons. Well, we really want to know, are the ribbons different or are they all the same? Because if you're giving out first, second, and third place ribbons, someone would be like, maybe not disappointed, but they'd be much more excited to get first place than they would to get third. So in that situation, order would matter, and we'd be looking at a permutation. But if all of your ribbons are the same, they're all just honorable mentions maybe, then we're going to stick with a combination. Okay, so as we continue with this probability unit, you're going to have to decide, does order matter or does it not? Let's do one more example. Let's say that we're looking at this adorable litter of golden retriever puppies, and we are going to pick a puppy. It's my husband. And there are 10 puppies here. Now, if we're going to get to pick 2, we need to decide, does order matter? Are you going to still get to take home both puppies? Yeah, so it doesn't matter which puppy you pick first. You're going to get to take both home. So that would be a combination. But realistically, we're probably only going to get to pick 1 puppy. How many lucky people get to take home 2? So let's try calculating 10C1 in our calculator instead of doing it by hand. So if you have a scientific calculator, you're going to be looking for that PRB button. You'll press the 10 first, then PRB, then the 1. I'm going to go ahead and model it on the graphing calculator. So we can do the same thing. I can say 10. To get to those probability keys, you're going to have to press math next and go over to the probability menu. I'm going to choose C and then 1. So there were 10 puppies. I'm going to get to take home 1. When I press enter, we get 10 out. Which, does that make sense? Only 10 ways, because if you're only getting to pick 1. But what's interesting is whether we do a permutation or a combination, if you're only selecting 1, you will end up getting the same answer. Because if there's only 1 puppy, there is no way you can rearrange the 1 answer, the 1 puppy. So permutations and combinations sometimes do come out to have the same value, and that is when you're only getting to select 1. All right, so that is it for our lesson. You're going to go ahead and do the practice problems. Let us know if you have any questions. I know this is getting a little bit more complex. You do have an AFL to do when you're feeling ready. And yeah, thanks for stopping by.